According to the National Electrical Code, a single 110-volt circuit can handle a maximum of 20 amps, which is equivalent to 2400 watts. The NEC mandates that each circuit must be protected by a circuit breaker or fuse that is rated for the maximum amperage permitted on a specific circuit. Now let's consider some approximate breakdowns of electrical loads, starting with a living room setup. If you have 10 outlets, and we estimate each requires 15 amps, that's 150 amps just for the outlets. If you have 2 ceiling fans, each drawing about 2 amps, that adds up to 4 amps. Then consider 4 recessed lights, each using roughly 1 amp, totaling another 4 amps. Summing these up, the total load for the living room comes to 158 amps. Now let's move to the garage. 10 outlets, again at 15 amps each, total 150 amps. 2 automatic garage door openers, each requiring around 15 amps, add another 30 amps. Finally, 3 outdoor lights, each at 15 amps, bring an additional 45 amps. The total for the garage then is 225 amps. Adding the living room's 158 amps to the garage's 225 amps gives us a combined electrical load of 383 amps. This figure far exceeds the NEC 20 amp limit for a single circuit. Therefore, it's evident that the existing wiring setup is causing a significant overload on the circuit. To address these safety concerns and ensure compliance with NEC, several steps are recommended. Firstly, install a dedicated circuit specifically for the living room. This circuit should have a minimum capacity of 20 amps to accommodate the 158 amps of load. Secondly, install a separate dedicated circuit for the garage. This one should have a capacity of at least 30 amps to handle the 225 amps of load. It's crucial to ensure that both of these circuits are protected by appropriately rated circuit breakers or fuses. Here are some additional points to consider. The electrical wire used must be adequate to handle the amperage load on each circuit. It's recommended to consult with a qualified electrician to determine the correct wire size for your specific needs. The capacity of the circuit breaker or fuse should be slightly higher than the actual amperage load on the circuit. For example, if a circuit has a load of 20 amps, a 25 amp circuit breaker would be a suitable choice. Lastly, it is vital that all electrical circuits are properly grounded. Grounding is an essential safety measure that protects against electrical shock.